We are asked to find the two-digit number that equals 3 times the sum of its digits. Let's model the number with a tens digit and a ones digit, and then write an equation. Step 1. Let the tens digit be t and the ones digit be u. A two-digit number with tens digit t and ones digit u is 10t plus u. Step 2. The problem says the number equals 3 times the sum of its digits. That is, 10t plus u equals 3 times the quantity t plus u. Step 3. Expand and collect like terms. On the right we have 3t plus 3u. Move terms to one side to get 7t minus 2u equals 0, which is the same as 7t equals 2u. Step 4. Digits have limited values. The tens digit t is between 1 and 9, and the ones digit u is between 0 and 9. From 7t equals 2u, we can write u equals 7 halves times t. For u to be an integer, t must be even. Let's test even tens digits. T equals 2, t equals 4, t equals 6, and t equals 8. For t equals 2, u equals 7. That is a valid digit. For t equals 4, u equals 14, too big. For t equals 6, u equals 21, too big. For t equals 8, u equals 28, too big. So the only valid pair is t equals 2 and u equals 7. Step 5. Therefore t equals 2 and u equals 7, so the number is 27. Let's check. 3 times the sum of its digits is 3 times the quantity 2 plus 7, which equals 3 times 9, or 27. The condition is satisfied. Final answer, 27.